Welcome to KlassPM. Today now going to discuss about the sets. Sets. What is the meaning of sets? Means the collection of well-defined objects is called sets. See, here we are taking, as per our definition, collection of well-defined objects. Here we are saying well-defined here. How can we define this word well-defined? So it's a fixed. Whenever we are taking, as per our number system, we are having types of numbers like natural numbers, whole numbers, integers. How we are deriving that? We have some rules and regulations. In that manner, we are defining the number system in the systematic manner. That is called sets. Here we are defining the set as well-defined objects. In the set we are having the objects. Objects are called elements. We can take the objects as elements in the set. Sets are denoted with the flower brackets. We are taking always sets with the capital letters. In the sets we are having some elements. These elements always should be small letters. So here we are taking the sets with the flower brackets by deriving as capital letters. In the sets what we are taking, the elements are with the small letters we are taking. So this is called sets. Here we are having types of sets. We are having types of sets, and how can we work in that sets? Before going to discuss about the types of the sets, we need to discuss some more important points in the sets. The first one is how we are defining, how we are writing the sets in the formation of roster form, and the second one is set builder form. What is the meaning of roster? What is the meaning of set builder? We are going to discuss these two topics here. Roster. How can we derive this roster form? A set. I am taking set A is a collection of quadrilaterals. Collection of quadrilaterals. We are saying, simply we are saying A set is a collection of quadrilaterals. How can we take this one in the roster form? Means we are taking this one by taking A as a set and taking, as per our condition, sets as with flower brackets, X such that we are taking. X such that. This symbol is called such that. X such that X belongs to quadrilateral. This is the roster form. We are taking X and X, means whatever we are taking X, this is called quadrilaterals. Quadrilateral we are having types. So like square, rectangle, trapezium, so on. So these are comes under the set A. The formation of the quadrilaterals we are writing, this one is roster form. Coming to the next one, set builder form. In the above we have discussed about the roster form. What we written, collection of quadrilaterals. I written in the formation of X such that X belongs to quadrilaterals. Already I discussed about the quadrilaterals, how many types we are having. So what we are writing, that in the formation of set A as square, rectangle, so on. These are the set builder form. Means we are building the set with the condition, with the given option, with the given particular question. Based on the question we are building that set. This is called roster form. This is called set builder form. Now we are having types of sets. we are having here basically three types. We are having three types of sets. The first one is finite set. Finite set, and second one infinite set, and the third one is empty set. So we can derive this one as per the types we are having. So finite means in that word only we are having the meaning finite. What we are taking the set, that set should be having the finite, fixed. What we are taking, that is called finite. We can derive, it's a fixed, it is the finite. Infinite, we could not fix the particular set, it is infinite, endless, we can't estimate, this is called infinite. And in the third set we are having type, that is empty. In that word only we are having empty, nothing is there in the set. These type of sets we are having. Here finite set, how can we take? The example for the first one, finite set. We are taking set A is equal to, we are having 1, 2, 3, 4, 5. That's it. It is the fixed finite. We are having 5 elements. Here the second one example we are taking here, infinite. We are taking A as, how can we derive this one? So multiples of 3, it is the infinite set. We can't stop somewhere, we are having infinite multiples. This is the infinite set. And coming to the third one example, empty set. Already we are having empty, no element is there in the set. This is called empty set. This is the infinite set, this is the finite sets. These are the types we are having in the sets. I will take this one as a finite set. It's a fixed, it's a not defined, and no elements. So in this manner we can say the types, definition, infinite, finite, and empty. Basic operations on sets. Next topic, basic operations on sets. Basic, we know, operations, we know that. How can we apply the basic operations on sets? Like we are having addition, subtraction, multiplication, division. These are the basic operations in our mathematics. Here also we are applying basic operations like addition, subtraction, and we are taking here union and intersection. Subtraction also we are taking here. So how can we apply? The first one, union. Union sets. In the word we are having union, combining, joining, mixing, that is called union. Whenever we are taking two sets, here I am taking 1, 2, 3, 4. This is a set, and B is a one more set we are having, and 4, 5, 6, 7. So these are the two sets I am having. So what is the A union B? It is the union we are taking. This is called union. The word it is denoted by U, capital U. A union B, it is the union. So what is the meaning means? We are taking the element A, 1, 2, 3, 4, and union B, we are having 4, 5, 6, 7. We are combining that collection of both the sets. Here we are taking 1, 2, 3, 4, 5, 6, 7. So in the both the sets we are having the common elements we are taking, and all comes under the one set, it is called union. But here in union set we should not take the repeated elements or the values. This is the union set. Here the value or element 4 is repeated, but we are taking only one time. This is the meaning I am saying. You should not take the repeated elements in the union. Coming to the next one, intersection. Intersection means what we are having the common elements in the both or more than the sets. Okay. So coming to the set A, we are having here, again I'm taking 1, 2, 3, 4, 5 here, and B set is I'm taking as 4, 5, 6, 7, 8. So we are taking intersection as A intersection B. This is the intersection we are taking. This is called intersection. Reverse of U, capital U, we are taking. This one is intersection. So here I am taking 1, 2, 3, 4, 5. It is the A set intersection, and 4, 5, 6, 7, 8. The B set having the elements. The values we are taking here, A intersection B, means which are we are having the common. In the set A we are having 4, and B set also we are having 4, and 5 also we are having. So 4 and 5 we are having the common elements in the both the sections. This is called A intersection B. Next topic, disjoint sets. Disjoint sets. In the word only we are having the meaning disjoint. No set should not common. Different sets we are having. That is called disjoint sets. Where we are taking A, the elements 1, 3, 5, 7, 9. I'm taking, and B set we are having 2, 4, 6, 8. So here no common element in both the sets. These type of sets are called disjoint sets. We should not take any element as common. This is the name of the disjoint sets. This is the meaning. And coming to the difference of sets. Difference, we know we need to subtract the values or elements from one set to another set. How we are applying, that is the in our regular manner only we are taking here also difference of the sets. We are taking set A 1, 2, 3, 4, 5 I am taking as, and B I am taking here 4, 5, 6, 7, 8. These are the two sets I am having. So difference, I am taking A minus B. I am subtracting B set elements from the A set. This is the mean. So I am taking here 1, 2, 3, 4, 5 minus B set we are having 4, 5, 6, 7, 8. So in the values how can we take? So should not take the values of 1, 2, 3. We are taking here 1, 2, 3 we are removing from the A set to B set we are taking. So this is the A minus B. So this is the disjoining sets we are having. No common elements here. Here we are removing the some elements we are having in the next set or the B set. That is the difference we are taking. Next one, equal sets. Here equal set means whenever we are taking two or more than two sets, the sets should be having the equal values of the elements. This is called equal sets. So what we are taking 1, 2, 3, 4, 5. It is one set I am taking, and B set I am taking here 5, 4, 3, 2, 1. So I changed the order, but all elements in the A set and B set should be same. These type of sets are called equal sets. So here we are taking means A subset or equal to B, or B subset or equal to A. So here we can see every equal set is a subset itself we can derive. So A and B are subsets of itself. Both are equal. From this we can say A equal to B. This is the equal sets. Next one, universal set. So universal means we discussed about the numbers, natural numbers, whole numbers, real numbers or quotient numbers, whatever we are having, types of numbers, these all numbers comes under the real numbers, we know very well. So here the real number is called universal set, means we are having the natural number in the real number, then it is called subset of real numbers. Natural numbers are subsets of real numbers, and whole numbers also subsets of real numbers, means from these we can say natural numbers are subsets of whole numbers. Here in this manner we can say the universal set. So we are defining universal set with mu. This is called mu. And one more letter we can use with capital U also. These are the way we can use the universal sets. So here we are having Venn diagrams. Our next topic is Venn diagram. Venn diagram means it is a closed figure made by the closed curves or rectangular shapes. We can show the sets to understand easily. We are using this Euler's Venn diagram or Venn diagram. How can we take the Venn diagrams? If we are having union, intersection, difference and disjoint sets, how can we represent that all sets in the Venn diagrams? Let us consider here I am taking A and B, two sets to represent the Venn diagrams for different ways. Here I am taking A as A, B, C, D, it is a one set, and I am taking here C, D, E, F is B set. So how can we represent A union B? So as per our regular procedure I am taking A, B, C, D union C, D, E, F we are having. So these are the two sets. Union means we need to take all elements. So A, B, C, D, E, F. How can we represent this set in the Venn diagram? See, I am taking here in a rectangle, and again I am taking A set, and one more set I am taking here B. In the set what we are having, A set having some elements and B set having some elements. So A set having A, B, C, D I am taking here, and B set having C, D and E, F. So here we are representing that AB sets in the union as Venn diagram. So we are taking this one as completely drawing with a shading with the lines. So this is the Venn diagram representation for A union B. So all will come under union. And coming to the intersection, I am taking A intersection B. What we are having? A intersection A, B, C, D, elements of set A, intersection, and C, D, E, F, elements of set B we are having. A intersection means we need to take the common elements of the both the sets. So here we are having A, B, C, D, and we are having C and D having common. So this is the A intersection B. How can we represent this one? Here we are having A, B, C, D, and here we are having E, F. So this part only we are taking. The common part is this one only. We are taking, this is the intersection part. This is the complete A union B, and here it is the A intersection part. So it is represented with E, here C and D. C and D are the set A intersection B. Next, third one I am saying difference. How can we represent the difference? I am taking here A set as 1, 2, 3, 4, 5 and B set as we are taking 4, 5, 6, 7. Right. So coming to the difference, I am taking A minus B. So here I am taking set A 1, 2, 3, 4, 5 and minus B set 4, 5, 6, 7. So difference we are taking A minus B as we are taking here 1, 2, 3. So how can we represent this A minus B set in the Venn diagram? I am taking here A set and here I am taking B set, A and B. Here I am taking the values what we are having here 1, 2, 3 and I am taking here 4 and 5. Here B set we are having 4, 5, 6, 7. So which part we want to remove means then we are taking this one. This is the A minus B Venn diagram. Next one, universal set. How can we represent universal set? Here I am taking A, B and mu as universal set. I am taking universal set as 1, 2, 3 so on up to 10. It is a well defined set. We are having the natural numbers up to 10. Then coming to the A set, I am taking only the odd numbers 1, 3, 5, 7 and 9. And coming to the B set, I am taking 2, 4, 6, 8 and 10. So here this set is only odd numbers, this set is having only the even numbers, but in this set both we are having. So we know universal set means we are having all elements in the one set. So the remaining sets whatever we are having, the elements that should be in the universal, these type sets are called subsets of the universal set. So here we are taking the universal set. How can we represent? I am taking the universal set, intersectional part are closed figures. Always we are showing the universal set with a rectangle shape only. So here we are representing the sets whatever we are having. Different sets we can show. Here it is the A set and it is the B set I am taking. In the universal set we are having all, means in the set 1 A we are having 1, 3, 5, 7, 9 and B set we are having 2, 4, 6, 8, 10. So here that all elements of A and elements of B having in the universal set means we can consider these set elements should be in the universal. Next one we are taking here disjoint sets. How can we represent the disjoint sets in the Venn diagram? See, I am taking values of A 1, 3, 5, 7 and values of B means set we are taking 2, 4, 6, 8. So how can we take disjoint sets in the Venn diagram? See, here I am taking the values A and values B I am representing here. So values A have 1, 3, 5, 7 and here values B so 2, 4, 6, 8. In the both the sets we does not have any common element. In this manner we can represent the Venn diagrams. And one more point we are having here, one note, the elements in the sets we are denoted number of elements is 10. How can we say? So these 10 elements should be having in the set A. So total number of elements in the set we are seeing the set number of elements denoted with n of A.